You click a link and poof, a web page just appears. Have you ever stopped to wonder what actually happens in that split second? It's not magic, I promise you. It's an invisible, insanely high-speed journey that a tiny piece of your data takes across the globe and back. And today, we're going to follow that journey, step by step.
Think of this as a hero's journey, but for a single data packet. Here's our map for the adventure. First, we'll see where our packet is born, inside your local network. Then, how it finds the door to the outside world. We'll check out the clever disguise it has to wear, follow its travels on the information superhighway, learn the rules of the road it has to follow, and finally, watch its triumphant return home. Let's get into it.
Okay, so our whole journey kicks off right where you are, in your home, in your office, inside what we call your local network.
This is what's called a local area network, or LAN for short. It's basically a private little club that connects all of your devices in one place. Your phone, your laptop, that smart TV, the printer, they're all members, and they can all talk to each other directly inside this club.
Now, every device in this club has two really important identities. First, you've got the MAC address. Think of this like a social security number. It's permanent, unique, and burned right into the hardware from the day it was made. Then you've got the IP address. This is more like a temporary mailing address that's only good for as long as you're connected to this specific network.
So how does your phone or laptop get that temporary IP address? Does it just make one up? Nope. The second it connects to the network, a service called DHCP, you can think of it as the network's rental agent, just automatically hands one out. It says, here, use this address for now.
Okay, so who's managing all this local chatter? That would be the switch. The best way to think about a switch is as the local mailroom for our LAN. Its entire job is to make sure a packet that your laptop sends to your printer gets delivered only to the printer and not to, your roommate's gaming console.
And this is what makes the switch so smart. It's not just a town crier shouting the message out for everyone to hear. No way. It looks at the destination MAC address, that permanent hardware ID, and it creates a direct, private line just to the device that's supposed to get the message. It's super efficient, and it keeps things private.
So, our packet is a pro at talking to its local neighbors, but we want it to go out and see the world, right? Its destination is out on the big, wide internet. So, how does it find the exit?
Well, every local network has one official front door. It's called the default gateway. And for pretty much all of us, that's our router. Any packet that needs to leave the local neighborhood absolutely has to go through this front door first.
But there's a tiny little puzzle here. Your computer knows the router's IP address, its mailing address. But to actually hand off a packet locally, it needs that permanent physical name, the MAC address. So what does it do? It uses a clever little protocol called ARP to basically shout across the whole network, hey, who has this IP address? The router hears the call and says, that's me, here's my MAC address. And boom, the packet can now be delivered right to the front door. All right, our packet is at the front door, ready to hit the road, but not so fast. Before it can step outside, it needs a disguise, a really clever one. Why? Because that private IP address it was using inside, it's totally illegal on the public internet. It's like trying to use your library card as a passport. It's just not going to work. And here's the fundamental problem this whole disguise thing solves. Think about your home. You've got, 10, maybe 20 devices. Your phone, laptop, smart speaker, a tablet. They all have their own private IP addresses. But your internet service provider, they only gave your entire house one single public IP address to share with the world. We just started running out of addresses.
The solution is an incredible trick called Network Address Translation, or NAT. As our packet leaves, the router, our gatekeeper, strips off its private internal IP address and stamps on the single public IP address. It's a brilliant disguise that lets all your devices share one public identity. And don't worry, the router keeps a secret little table so it knows exactly who's who when the reply comes back. Disguise on, passport in hand, our packet is finally ready. It steps through the gateway and onto the vast, sprawling, global network of networks, the Internet. See, the Internet is the ultimate wide area network, or WAN. Unlike our cozy little LAN at home, this thing spans the entire globe, connecting millions upon millions of other networks all together. So out here in the wild, our packet gets passed from router to router in a gigantic, high-speed relay race. Each router takes a look at the destination IP address and makes one simple, lightning-fast decision. What's the very next hop that'll get this packet closer to where it's going?
This can happen dozens of times, all in a few milliseconds. It's wild.
And just like that, our packet has arrived. It made it to the correct public IP address of the server it was looking for. But think of that server as a massive apartment building. Getting to the right street address is great, but that's not enough. How does the packet know which specific door to knock on?
That's where port numbers come in. They are literally the apartment numbers for data. An IP address gets you to the right building, but the port number, which is attached to that data packet, tells the server exactly which application this data is for.
And here are some of the most common doors you'll see. Port 80, that's for standard web traffic. But check out port 443. That's for secure, encrypted web traffic. That's the HTTPS you see in your browser with a little lock icon. Super important. Then you've got others, like port 25 for sending email. Every service is listening at its own special door.
And there are two main ways to knock on these doors. You've got TCP, which is the careful, reliable one. It's like sending registered mail. It checks to make sure every single packet arrives safely and in the right order. Perfect for websites and email. Then you've got UDP. UDP is all about pure speed. It just throws the packets out there and hopes for the best. It's great for video streaming or online gaming, where losing one tiny packet isn't the end of the world.
So the server gets the request, processes it, and now it has to send a response. So it creates a brand new packet to send back to you. And guess what? The entire incredible journey we just witnessed, it happens all over again, just in reverse.
That return packet zips across the internet, straight to your router's public IP address. And this is where the router's little secret NAT table becomes the hero. It looks at the packet, checks its notes, and goes, aha, I remember this conversation. This one is for the laptop at private address 192.168.110. It swaps the addresses and sends the packet home. Journey complete.
So, as our packet gets home safe and sound, here's the big takeaway. The IP address gets the data to the right house, but it's the port number that tells it which specific door to use. And using those secure ports, like 443 for HTTPS, well, that's the difference between sending a postcard and sending a letter in a locked box.
And the most mind-blowing part of all this? That entire round trip. That incredible, invisible dance between all this hardware and all these protocols, sometimes across continents, it all happens in less time than it takes you to blink. Thousands of times a day. When you really think about all those steps, the local delivery, the disguise, that global relay race, what part of it just makes you go, wow?